So we're beginning this video reviewing what we learned yesterday, sum and difference of two cubes. The sum of two cubes formula is the binomial a plus b times the trinomial a squared minus ab plus b squared. We just explained that it's really easy to memorize this because the first binomial will be identical to this without the cubes. So take off the cubes and you got a plus b, that's the first binomial. Then of course you have a squared, you have ab, and you have b squared. If your binomial here has a plus, then the middle term has to be a minus. If your binomial has a minus, then the middle term has to be a plus. The a squared will always be positive, the b squared will always be positive. And that's the easy way of memorizing this formula. So let's actually write out the difference of two cubes, a cubed minus b cubed. That will be the binomial a minus b. Again, you just rewrite it, but without the cubes. So it'll just be a minus b. There it is. And now for the trinomial, you have a squared, you have ab, you have b squared. We did say anything squared is always positive. That'll help you remember that this is always positive. B squared, anything squared is always positive. That'll help you remember that that's always positive. Now, if this was a minus, which it is, then this middle term has to be a plus. And that's it. That's the strategy to help you memorize these two formulas that are called sum and difference of two cubes. So what does this formula do? It allows you to take a complicated higher degree polynomial and factor it, right? Check this out. This is as ugly as it gets, I guess. Hold on a second. So we have 27 minus 64x to the sixth. You should see the 27 and recall that that is a cube term. You should see 64 and you should recall that it's a cube term. And you should think, well, could I change x to the sixth to look like something cubed? You see, in order for you to really know your a and your b value, it is essential that you set this up. Right below it, just set this up. Something cubed minus something cubed. Because you need to be able to write it in this manner to be able to identify your a and your b. Okay, so what number would have to belong in here in order for this to truly be a 27? 3. That is exactly right, Jack. Thank you. So that is a 3 right there. Now, it's not just the number, but what belongs in here that if I multiply it with itself 3 times, it'll give me 64x to the sixth. It's okay if you give me a wrong answer. Okay, 4 for sure. So, I mean, if I put a 4 right here, 4 times 4 times 4, that'll give me 64. But what about the x to the sixth? So, I need some x's in there. What do I do? Like, if I just put one x in there, well, 4x times 4x times 4x, that'll give me 64x to the third. But like you said, Jack, right there with your sign language right there, if you put a square, 4x squared, then yes, 4x squared times 4x squared is 16x to the fourth, and 16x to the fourth times another 4x squared is 64x to the sixth. Remember, power to a power, you multiply. So this is essential, and that was on the notes yesterday, that whenever you have a sum or difference of two cubes, you have to set it up as something cubed and something cubed in order for you to identify your a and your b. Now that you have identified your a and your b, you'll be able to plug in your a right there, right there, and right there, and your b right there, right there, and right there. Now, if you have just the number 3 and just the letter x, then yeah, you don't really need parentheses. But because we do have 4x squared, it's more than just a number, it's more than just a letter, it even has a power. It's very important that you use parentheses, particularly on your trinomial. On the binomial, it's pretty easy. What is the binomial? It's the same exact thing, but without the cubes. So what am I going to write in there? 3 minus 4x squared. Yay? Nay? What the hey? Okay, yeah, you guys are saying yay. All right, so now let's jump to the trinomial. The trinomial is a little bit more fun, especially because of this guy. So I'm not just going to write 4x squared squared, because that's going to be incorrect. I'm going to use parentheses. If you have more than a single letter or more than a single number, please use parentheses on your trinomial. So go parenthesis, squared, plus parenthesis times parenthesis, plus parenthesis squared. Okay? So the a value is 3, put a 3 right there and a 3 right there. The b value is 4x squared. Probably should have used a different color. This is all getting messed up. All right, so let me put a 4x squared right in there in blue to remain consistent, 4x squared. And over here as well, I want to put a 4x squared in there, 4x squared. Okay, so we need to work on the trinomial part. So let's zoom in just for a second. Well, let's not zoom in. Let's work on the trinomial part. So we have 3 squared, that's 9. We have 3 times 4x, that's 12, actually x squared, that's 12x squared, so plus 12x squared. And at the very end, we have plus, what is 4x squared times itself? Because that's what it's saying. It's saying 4x squared squared. Well, that's 4 times 4 is 16, and you have x to the second, power to a power multiply, so you get 16x to the 4th. And ladies and gentlemen, bring down your binomial, 3 minus 4x squared, and we have our completely factored form of this original 6-degree binomial. This is our completely factored form right there, using the formula. Pretty cool, right? We will have this formula on Friday's test. Please memorize it. And this one's pretty hard. There are definitely easier ones. We're going to have one like probably that says like x to the 3rd minus 8. Oh, that's easy. Way easier than this. But that was just a little taste of yesterday, a little refresher. Let's move this out of the way. Let's jump to the remainder theorem, also known as the factor theorem. So back when we did synthetic division, we also covered synthetic substitution. It was an alternative way of plugging in a number. So like let's say I had p of x as this function. Now if I told you plug in 3 with the notation p of 3, well, you could plug in a 3 right there or a 3 right there, or you could do synthetic substitution. Now, on the previous video that I've already uploaded on Google Classroom, you could see that stuff. I just want to reiterate synthetic substitution. I'm not going to go over all of these. Let me just do one of these that's kind of simple. So it's not synthetic division, it's synthetic substitution, right? So what goes inside the box? Anybody? What goes inside the box? If I want to find g of 4, you put a 4. You don't think opposite. You just take that value that they want you to plug in and you plug in that 4, okay? So we also need a list of our coefficients. The number in front of the x to the 3rd is 1. The number in front of x squared is 3. The number in front of x is 2. The number that's all by itself without a letter, the constant, is negative 50. Okay, so put a line. As you go down, if you forgot, you combine. 1 plus nothing is 1. As you go up, you multiply. 4 times 1 is 4. As you go down, you combine. 3 plus 4 is 7. As you go up, you multiply. 4 times 7 is 28. As you go down, you combine. 2 plus 28 is 30. As you go up, you multiply. 4 times 30 is 120. As you go down, you combine. Negative 50 and positive 120 is positive 70. Do you understand that? Yes? Now, what does this 70 actually mean? It means that if I were to plug in a 4 right there, 4 cubed, I get a 64, 4 squared is 16, times 3, 48, I don't know, and then 2 times 4, 8, and then minus 50. If I do all that math, my answer will be 70. Okay? So if you really wanted to, you could actually plug in the 4 and work it all out, or I think it's faster to do synthetic substitution, all right? So the big difference between synthetic substitution and synthetic division is that in synthetic division, like up here on this first problem, it says your p of x function is this, and they want you to divide this by this binomial x minus 3. Okay, you plug in the opposite of the constant. And I've never explained why we plug in the opposite of the constant of the binomial that we're dividing by, but I will explain that in a couple of minutes shortly, okay? Let's jump to the actual new stuff. That's all been reviewed. So here is the remainder slash factor theorem. What is the factor theorem? the binomial x minus r is a factor of the polynomial p of x if and only if p of r equals 0. What? What the heck is that? Is this a different language? Yeah, kinda. All right, let me break it down for you. Let's take it back to the 4th grade. Is the number 4 a factor of 12? What do you think? Yes or no? Come on, people. Anybody there? Anybody awake? Is the number 4 a factor of 12?
Yes.
Yeah, I mean, let's, all right, even simpler. What does factor mean? It's a reverse distributed property. It's where you produce multiplication, right? So if I say, is 4 a factor of 12, will 4 times something give you 12? Yeah, right? So is 4 a factor of 12? Yes. Is 2 a factor of 12?
Yes.
Is 6 a factor of 12?
Yes.
Is 5 a factor of 12?
No.
No. Okay. So check this out, guys. When I say is 4 a factor of 12, I already know 4 is a factor of 12. If I divide 12 by 4, my remainder will be 0, right? 4 times 3 is 12. When I subtract, my remainder is 0. Okay. Now, what if I were to do 5? Like if I say 12 divided by 5, back in the 4th grade, you would say 5 times 2 gets you close, 10. You subtract, you have a remainder of 2. So if your remainder is 0, then you could rest assured know that that divisor is a factor, okay? 12 divided by 4 is 0. 4 is definitely a factor of 12. 12 divided by 5, the remainder is not 0, it's 2. There's an actual remainder. 5 is not a factor of 12. So let's read this one more time. The binomial x minus r is a factor of the polynomial. So if and only if your remainder is 0. So you're going to have a polynomial right here instead of 12. And you're going to have a binomial out here, maybe like x minus 2 or x plus 3. And if your remainder is 0, then you'll know that that x plus 3 is a factor of the original polynomial, if your remainder is 0. Does that make sense? See, the remainder theorem, the factor theorem, what is the theorem? It's the truth in math, all right? So what is the truth about factors of polynomials? The truth about factors of polynomials is if you take a polynomial and divide it by one of its factors, the remainder will be 0. That's the fact. Let me repeat it. The fact in math that we're learning about factors is that when you take a polynomial and divide it by one of its factors, the remainder will be 0. Do you get that? Very similar to numbers. 4 is a factor of 12. Why? Because the remainder is 0. Right? If I say 86, is 43 a factor of 86? Well, if your remainder is 0, then yeah, 43 is a factor of 86. Okay? If your remainder is not 0, it's not a factor. Does that make sense? Okay? So down here, our first question with regards to the factor theorem. Determine whether this binomial is a factor of this cubic polynomial. Okay, what do we know? If x minus 5 really is a factor of that cubic polynomial, if I were to divide it, my remainder should be what? 0, right? Make sense? So let's actually do that. Does anybody want to do long division, or should we stick with synthetic? Synthetic, it's way faster. That's absolutely right. Let's use synthetic. So in synthetic division, what number do I put inside the box? Positive. We put positive 5, right? Now, should I do this right now? Yeah, why not? Okay, check this out, guys. When you take a polynomial and you factor it, you end up with, side note, okay, I apologize, side note. When you take a polynomial and you factor it, you end up with something times something, and if it were equal to 0, then you would use 0 product property to split them and solve, right? You guys following me? Okay, so if I were to factor a polynomial and I end up with something times something, I could split it and say this equals 0 and this equals 0. So whatever this is, I'd have to solve it, like if it were x plus 2, I'd have to solve it by going plus 2 plus 2. And that's exactly why, when we're doing synthetic division, we plug in a 5 instead of a negative 5. because if this really is a factor and you set it equal to 0, your answer will be x equals 5. That's why we're plugging in a 5 right there. I hope that kind of makes sense. It's just a little taste. You're going to have to know this in the future, not right now, okay? But yes, the reason why we plug in the opposite is because if you set x minus 5 equal to 0, what's your answer? X equals 5. That's why we actually plug in a 5 instead of a negative 5. Anyways, let's go back to synthetic division. I've always said just think opposite. I guess that works right now. We'll have to think about it more later. But right now, the coefficients, we have a 1 in front of the x to the third, a negative 7 in front of the x squared, a positive 7 in front of the x, a 15 all by itself. There are no missing x powers, so we are able to just start this synthetic division. 1 plus nothing is 1. 5 times 1 is 5. Negative 7 and 5 is negative 2. 5 times negative 2 is negative 10. This will give us a negative 3, and a positive 5 times negative 3 is negative 15. And then, last but not least, the remainder is 0. The remainder is 0. Of course the remainder is 0. Why? Because they told us, actually they didn't tell us, they're asking us, is this a factor? So if it is 0, then that is a factor. Does that make sense? So now for a fact, I know that x minus 5, why is it going with highlighter? My bad. Sorry about that. I know that x minus 5 is part of my factored form of the original. X minus 5 is a factor. Okay? Now, let's take this a step further. So the answer to this is yes, x minus 5 is a factor. Why? Because the remainder is 0. And if the remainder is 0, then we know it's a factor. Kind of like, is 4 a factor of 12? Yes. Why? Because the remainder is 0. Is 5 a factor of 50? Yes. Why? Because when you divide 50 by 5, the remainder is 0. Is 7 a factor of 50? No, because when you divide 50 divided by 7, you get a remainder. And the remainder theorem, the truth about the remainder, is if the remainder is 0, then it is a factor. The divisor is a factor. Fun stuff, I know. But let's take this a step further. So the answer to this question was yes, x minus 5 is a factor. But let's take it a step further. You guys see these blue numbers down here? This actually produces what the book calls depressed polynomial. Yeah, that polynomial wants to, it feels really sad. It's lonely. It's called depressed because it gets smaller. So this is a depressed polynomial. And if I started with x to the third and I actually divided by x, then this should be an x squared. So I could actually write out this depressed polynomial. I could write it out as 1x squared minus 2x minus 3. Okay? So what I'm saying is, we know that this is a factor. This is the depressed polynomial. If I were to distribute x times that, x times that, x times that, and then negative 5 times that, negative 5, combine like terms, I will end up with the original cubic polynomial. However, let's write it over here on the side. So we have, we have x minus 5, and let's write down that depressed quadratic polynomial. I don't need the 1 in front of the x squared. Let me just write the rest like so. Could I continue factoring? And the answer is yes. That blue quadratic trinomial, it has no a value other than 1. It's 1. So you could continue to factor, or at least try to continue factoring, and think what times what is your c value that if you combine together is your b value, which is negative 2. So you could set this up, x, what times what is negative 3 that if I combine together is negative 2? That would be a negative 3 and a positive 1. Bring down the x minus 5, and believe it or not, we have completely factored this cubic polynomial. This is the completely factored form. Now, they didn't ask us to do this on this problem. All they asked us to do was to check if x minus 5 was a factor. I did synthetic division. My remainder was 0. Absolutely, that is a factor. But the additional knowledge that you're gaining right here is that these leftover blue numbers, that's what the book calls a depressed polynomial. It's sad, right? And all you got to do is write your constant, and then your x, and then your x squared, and you could continue factoring this. You won't always be able to do that, but in this case we were able to do that. And this is a completely factored form. If I were to distribute, combine like terms, distribute, combine like terms, it will take me to the original. So this is a completely factored form. Here's another little seed that I'm going to throw in your brain. If I were to set this whole original problem up, and if I were to plug in a -3 or a +3, the opposite of that, which is +3 right in there, it should also give me the remainder of 0, because this is a factor. If I had a -1 in the box, -1 that I get from here, then it should also give me a remainder of 0, because all of these are factors. And if they are factors, then you truly have a remainder of 0. Does that make sense? Okay. This is where it gets fun. Given a polynomial, this is a 5th degree, huge, disgusting, nasty polynomial, and they're telling you, they're giving you this truth that one of its factors is x minus 2. One of its factors is x minus 2. Okay? It says find the remaining factors. Dang. If I know for a fact, because they're telling me that x minus 2 is a binomial of that 5th degree polynomial, then what could I do? I could divide the original polynomial by this factor, x minus 2, which they're telling us is a factor, which means that I should get what at the end of the synthetic division?
0.
Thank you. 0. So let's do that. Let's actually plug in, let's plug in the -2. And where am I getting that from? Because they're telling us that this is a factor. And if I were to set that binomial equal to 0, I would add 2 to both sides. Wait, whoa. I'm glad I was explaining that. Inside the box goes a +2. And the reason for that is, if this is a factor, which it is, they tell us, so if I were to set that equal to 0, x minus 2 equals 0, plus 2 plus 2, that's why we plug in 2 inside the box, okay? Let's put the list of the coefficients. And again, this little explanation, I've never done that before. I've always said just think opposite of the divisor, of the constant of the divisor. So let's look at the coefficient, or the coefficients of the giant polynomial. We have a 1 in front of the x to the 5th, a -2 in front of the x to the 4th, a +4 in front of the x to the 3rd, a -8 in front of the x squared, a -5 in front of the x, and a +10 at the very end, the constant. It's going to be a long one. As you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. 2 times 1 is 2. As you go down, you combine. That gives us 0. As I go up, I multiply. 2 times 0 is 0. As I go down, I combine. 4 plus 0 is 4. As I go up, I multiply. 2 times 4 is 8. As I go down, I combine. This is weird. I'm getting a lot of zeros. Let's keep going. 2 times 0 is 0. -5 plus 0 is -5. And -2 times -5 is -10. And yes, the remainder is 0. Does that surprise me? Absolutely not. Why not? Because they told me that x minus 2 is a factor, so I know for a fact the remainder should be 0. If I would have gotten something else, I did something wrong. Okay? So yes, the remainder is 0 because they told us x minus 2 is a factor. So why did I do this? Because now I could pull up my depressed polynomial. Okay? Now, we already know that in my completely factored form, I will have x minus 2 in front because they're telling us that x minus 2 is one of its factors. But let's take these blue numbers and create a depressed polynomial. Okay, so if I started with x to the 5th divided by x, then this first term is no longer x to the 5th, it's now x to the 4th. It's depressed because it got smaller, right? So we're going to go 1x to the 4th, or just write down x to the 4th, and then plus 0x to the 3rd, but that's pointless to write plus 0x to the 3rd, so we're going to skip that and just jump to the plus 4x squared. And then instead of plus 0x, I'm going to skip that and just put the minus 5. Does everybody understand how I got this depressed quartic trinomial? Okay. Now, I need to attempt to continue factoring. And I hope that based on the skills that we learned yesterday and the day before, you could identify that this is a fourth degree and this is half of that power, which means that we could kind of force it to look like a quadratic trinomial, which means I could, if I made it look like, if I said, oh, this is an x squared plus 4x minus 5, let's do that on the side. If it said x squared plus 4x minus 5, I could factor it. What times what is negative 5? That if I add together is positive 4, that's a positive 5 times a negative 1. So I could factor that. And we learned that if this degree is double the power of the middle term, you could pretend that it's a quadratic trinomial. But instead of x and x, well, it's going to have to be an x squared and an x squared. So I am going to put that x squared and x squared. And now you could simply think, what times what is negative 5, that if I combine together is positive 4, well, that would be a positive 5 times a negative 1. You guys remember that skill from yesterday? Making a higher degree polynomial look like a quadratic? Okay, so let's now bring down the original x minus 2 that they told us was a factor. So we have these three parentheses that if I were to multiply together and combine like terms, distribute combine like terms, it would give me the original fifth degree huge polynomial. However, the question is, could we continue factoring further? Well, x minus 2 you can't, x squared plus 5 you can't, but x squared minus 1, that's technically a difference of 2 squares. In other words, this is a quadratic trinomial, or binomial, where you could think what times what is negative 1 that if you combine together is a middle value, which is nothing. What times what is negative 1 that if you combine together is nothing, it's a positive 1 and a negative 1. So I could actually continue factoring this x squared minus 1. So let me rewrite this whole thing over here on the side. I have the x minus 2 that they gave us. I have the x squared plus 5. And the x squared minus 1, I could rewrite it as plus 1 minus 1. And ladies and gentlemen, this is your final factored, entirely factored form of that fifth degree polynomial. I know, mind-blowing, right? Let's blow your mind even further. If this is the completely factored form, and I wanted to find where this fifth degree function, if I were to graph it, which I know is an odd degree function, and I know the leading coefficient's positive, which means that it has its end behavior in quadrant 3 and quadrant 1, I could also find out from this factored form where it will actually cross the x-axis, how many real zeros it'll have. And it actually crosses the x-axis at positive 2, at negative 1, and at positive 1. So it'll have 3 real zeros. It'll cross the x-axis at positive 1, negative 1, and positive 2. And this right here, if I set it equal to 0, it'd produce imaginary values. So this fifth degree function only crosses the x-axis 3 times. Of course, that's not what's asked on this question. I just want to link everything that we've ever learned together, all right? So I think this is already way too long. Let's stop right there. We'll continue with this tomorrow. I apologize. Hasta luego. Nos vemos mañana.
All right, so